The Electric Tape Revisited Lab by Cross Janetto. The purpose of this lab is we're trying to discover how much excess charge is formed on a piece of tape due to friction. And we are trying to discover if the charge is positive or negative and how many excess electrons. We are studying inductors and conductors and how do charged particles react when placed near each other. Specifically for this new lab, we are also covering how different modeling techniques give you better information based on what technique you use. The core principles are the same as the previous lab. Charged objects create an electric field at points in space. This electric field can interact with neutral objects. Two charged objects can generate a force on one another, and this force will either repel or attract, depending on the sign. Here's a preview of the lab. Here's the lab setup we had. And then on the left is the glow script model. We determined that the tape was negative in the first lab. We can show the electric force on the thing and the gravitational force and the amount of electrics charged on one piece of tape. This is an estimate using this model as a line charge. Equations we use to calculate the excess electrons are the same, using E field, force of electric field, and force of gravity, except this time we will be using calculus version of these equations and summations in order to add up individual pieces of the charge of the line. Data collection, since the tape is negatively charged, they would repel each other, which was our prediction, which was correct. The negatively charged tape was attracted towards neutral objects. We measured and gathered the mass of two separate pieces of tape. We charged two separate pieces of tape using friction, and we had one hanging from two books, so it could freely move up and down. We held the first piece of tape below the second, and then basically we measured how far it moved and also how much the force required to raise it. We also repeated the experiment to ensure accuracy. Here's a quick look at the code. We will be reviewing what it means in a second, but this is just a preview of what actually the code looks like. Here's the glow script modeling. We modeled the tape as a line of charge. As you can see, it's a bunch of different points of the charge, each with an even amount of the charge interacting with the line above. We calculate each individual piece of the electric field and the force and then add them up, and then use the previous equations to calculate E field, different forces, and excess charge. These are then modeled as vectors are on the charged objects. Calculating excess charge, we're assuming the tapes have equal charge and they are not a point charge this time, but act as an evenly distributed line of charge. Since we know the mass, we can calculate the force of gravity using the equation Fg. Since the floating piece of tape is stationary after it rose, we can assume that the downward force is equal to the upward force when the two charges are 1.7 centimeters apart. By setting the two forces equal to each other, we can solve for Q on one piece of tape. We can then divide the answer by the charge of electron and get the number of excess electrons on one piece. Again, we are assuming that this is floating midair and is stationary. Assumptions and possible errors for this technique. Assumptions, we are ignoring air resistance on the object. Even though it is stationary, we are ignoring air resistance as it travels. However, it doesn't really matter about air resistance because it is stationary floating. More importantly, we assume that each U-tape I made have had the same amount of charge evenly distributed on the length of the tape. Possible sources of error is that when the tape's in contact with our hands, it is losing charge as time goes, even though the skin is an insulator. This is why it's important to touch the tape as little as possible, because slowly electrons are transferring over to the object the tape is touching. The two tapes could have slightly separate charges, given we charge them at separate times, and other forces may be acting on the tape, such as tension. Discussion and conclusion. Negatively charged objects attract neutral objects and positive objects while repelling other negative ones. We proved this in the lab before. Charged objects produce an electric field. Additionally, more importantly, the total value of the point charge will be less than the line charge if the E fields are equal on the tape. This is because the tape is more spread out from the line charge, which means the charge is more spread out, and that means at different points along the tape, it is farther from the piece of tape in the center, so less force is generated. Our estimates differ because the distance between the charges, as I said, because the charge is distributed along different points on the tape, these points have different distances between the two pieces of tape. line of charge is more likely to be closer given a better represents what is actually happening, which is a bunch of different electrons throughout the entire uniform tape.